Okay, so in these next examples we take a look at some examples of simplifying by combining like terms. If you haven't watched the previous videos that review how combining like terms works, you may want to take a look at those first. So what we can do here in this problem, 15a minus 14 plus 7a plus 20, is we can make use of some of our arithmetic properties that say as long as I keep the signs in front of the numbers, I can rearrange this addition and subtraction problem. So I can bring my a's together. So the 7a, I can keep the plus sign in front of the 7a and bring it over beside the 15a. And then minus 14 and then plus 20. And so what I've done is I've just rearranged so my like terms are together. Remember, like terms need to have the same variables and the same exponents. And at this point now we can just combine like terms. 15 and 7 will be 22a. And then negative 14 plus 20 will be a positive 6. Okay, so at this point we just combine anything that's a like term, and then that's our final answer. We can't put 22a and 6 together because they aren't like terms. This next example brings some decimals into play. Now nothing changes except we're working with these nasty decimals. But we're once again going to put our number terms together and variable terms together. So I'm going to start off 2.6, and I'm going to bring the other number term over the 4.7. Since it has a minus, I'm going to keep that. And then I'm going to write down negative 4.1b plus 0.28. At this point we just need to add our decimal expressions, and if you want to, this is where technology can also come into play and be a little bit helpful. 2.6 minus 4.7 will be a negative 2.1. Negative 2.1. A negative 4.1 plus 0.28 will become negative 3.82, and because it's negative we write it down as minus. And then we keep the like term, the b. Minus 3.82b. Okay, so let's consider this next example here. 7.6xy minus 8x plus 19xy minus 15y plus 7x. So once again, we're going to be adding our like terms. So yes, I again have a decimal involved here at the beginning, at least, the 7.6xy. But it's not going to change how I handle things. I'm going to group my xy's together. So I'm going to 7.6xy and 19xy. And then at that point, we look for other like terms. I see I have a minus 8x to go with the plus 7x. And then I have a minus 15y that's completely lonely all by itself. So there's really nothing else I can do there as far as the y is concerned. So we go ahead and put our like terms together, right? Our xy's together and our x terms together. 7.6 plus 19 will be 26.6xy. Negative 8 plus 7 will be negative 1x. And then the 15y will just tag it along. Now instead of writing 1x here, if you wanted to, you could just write x. And that brings an important idea in here with a variable. I refer to it as the incredible invisible ones. See, when we have a variable like x, that x has a bunch of secret ones that are hanging around if needed. First of all, every variable that doesn't have a number in front of it has a 1 in front of it, although we often don't write it. And every variable that doesn't have an exponent written on it has a 1 as its exponent. And every variable that's not part of a fraction has a 1 in the denominator, whether we write it down or not. And so we bring these ones out when it's convenient. Okay.